So in this quarter joint, what we are going to learn is we have to create three parts. One part is first one is this rod end. Then after that we have to create this sleeve. Then after that we have to create this quarter. So once we create these three parts, then we have to adjust it. See here, there are two rod ends and one sleeve part, and after that there are two quarter parts. This quarter joint can be used to lock the sockets. So here what happens, if we are having two joints and if we want to join two plates, at that time we can go for this quarter joint. So here the thing is that all of them, they'll be created separately. Then after that, once they are created, this sleeve is kept as base part. Then after that, in this sleeve, we are going to join this rod end on this side also. Like over here, we are going to keep our one rod end, and in reverse way, in this like a mirror image, we are going to keep another rod end. So once we are giving these two, or once we are fixing these two rod ends on both side of this sleeve, then after that it will be still under constraint. It is not fully positioned because only this sleeve will be fully positioned, and here you can give any rotation to this rod end. So to constrain that, we are going to apply this quarter end on this particular slot. So this slot also will be having the what's that? This sleeve also will be having a rectangular slot over here, and even this rod end also will be having slot over here. That slot will be kept over here like this, and after this, then quarters will be kept on these two slots. So once we fully position those quarters, then we can log this quarter joint. I hope all of you understood this concept. Now we are going to read this diagram, and after that we are going to create the part according to this diagram. Today we'll create these two parts, or if it is possible, we'll start this quarter also. It's easy actually, all these things. But still, if you are not understanding any concept, then you can ask me at any time, okay? See here, first we have to see always whenever we are seeing this symbol, like if we are having this kind of symbol like this, yeah, like pi symbol. So when we are having this kind of symbol, at that time it shows that it is having it is like diameter of that much dimension. If they want to show it as a radius, at that time they will be specifying it as r. You can see it over here, r 60 is nothing but that is our 60 radius. Here we are having 30 diameter. Likewise, here also we are having 25 diameters. So here what we are having, this entire circular rod, okay, a circular shaft or circular rod, it is of dimension of 30 and it is having a end or extrusion end or protrusion end that is having 25 diameter. So it is 30 and this is 25 and you can see that this part is having the length of 86 So total length is 86 We have to create a circular rod of 86 Then after that we have to create another circular rod which is having 25 mm, and this dimension is not specified over here. When it is not specified or when it is unknown, at that time you can take any dimension which is according to you, like you can take 50 mm or 25 mm or 75 mm, 100 mm, anything you can take. Preferably you take 25 to 50 mm. Okay, so here we can take 25 or 50 mm. Then after that, this part is also having a slot over here. This dash means there is a hidden line. You have understood this in the previous solid section we have showed it like there is a hidden line means there is a part which cannot be seen in the front view or which cannot be seen in the view. So at that time, we'll be showing it as hidden line. So here hidden line means nothing but it is a cut section over here. Here a slot is there and that slot is represented by this hidden line or dashed line. And also it is shown like this axis line is given over here. That means with this axis line we have to create this 30 mm circle. And after that it is also given that at what distance it is 25 mm from the rod end it is 25 mm, and from there 25 mm it is measuring it about 36.5 mm. And also it is given that taper is 1 is to 30. Taper is 1 is to 30 means always we should know that always the dimension will be changing by 1 mm out of 30 mm. So here how much distance is there? What is the distance over here? It is exactly 30 mm. So if it is 30.5 over here, then here we'll be having minus 1. So this 36.5 will be reduced by 1 mm and this will be over 35.5 mm. Here it will be 35.5 mm. So if it is 35.5 mm, then what will be the dimension over here? What is the dimension over here? It is nothing but half of this thing is nothing but now we can know that if it is 30 mm, this will be over 15 mm, right? So if it is 15 mm, then we should be knowing that at 30 mm, 1 mm reduction will be happening or 1 mm increment will be happening. Like if you are going from here, like 35.5 mm, if you are going upwards at that time, it will be 35.5. If you are coming back or if you are coming in downward direction at that time, it will be 1 mm reduction. Here it will be 1 mm increment will be happening. So here, if it is half of the distance like 15 mm, at that time it will be zero point 0.5 mm. So here from here to here this will be increased by zero point 0.5 mm and from here to here it will be increased by zero point 0.5 mm. So this will be 36 mm. So the dimension between this point to that point will be 36 mm. These things we should be knowing. And apart from this they also have given that it's a it's having what is that chamfer of 2 mm and the chamfering angle is 45 degree. Okay, chamfering angle is 45 degree and it is about 2 mm. So at 84 mm if we take it and from there if you are making it 45 degree, this will be this total dimension will be 28 mm. Okay, 30 minus 2 is 28 mm. So here 1 mm will be there and at this side also 1 mm will be there. And from this dimension here we will be having 2 mm. And from this to this point we are having 45-degree angle. And the dimension of the slot, it is given over here. What is the radius of that slot? It is around 7.5 mm dimension. So this total dimension is 7.5 mm. So if it is 7.5 mm, if it is 7.5 mm, what is the radius over here? What will be the radius? If it is 7.5 mm, what will be the radius? Total diameter is 7.5 mm. So half of the 7.5 mm will be our radius. So 7.5 divided by 2 will be giving us how much? Around, I guess, 3.75 mm, right? So this will be our radius of arc, which is having 3.75 mm. And after this, here also we are having one round option, and in several parts also we'll be having round option that I'll teach you later. So if the dimension is not given, okay, if the dimension is not given over here, then we should go over here and we have to see the dimension. If it is not given, then you can take 1 mm or 2 mm or 3 mm, 5 mm, up to 5 mm you can take it. But most of the time that dimension will be given over here. Like all unmentioned fillets and rounds will be having radius of 3 mm. Okay, you can see that. You can see it over here. Always in this section it will be given. Okay. Now we'll be going to our solid edge, and we are going to create a solid part over here. So we are going to click on this solid part. So once we click on this solid part environment will be coming. We have already seen how to create this solid part because we have done it in last class. So what we are going to do it over here. First initially we'll be taking as it is given in the front view. Then we have to take either a right profile plane or front profile plane because we are seeing it in this direction, front profile plane. That's why I'm taking a right profile plane over here, and I'm going to draw my diagram. From that I'm going to create protrusion. So how to create this protrusion? First initially we are going to create a circle over here, a circle of dimension which is equivalent to, you can see it over here, I will keep it like this, which is equivalent to 30 mm. So this should be having 30 mm diameter. So this we are making it as 30 mm diameter. So we have created one circle. Then I'm going to click on this return option. Now either we can create it with non-symmetric end or we can go with symmetric extent. So if I select symmetric extent in both direction it will be created. Otherwise if I select this non-symmetric end, then only from one end it will be created. Preferably go with symmetric extent. So when you are going with symmetric extent, then it will be extended in both direction. And the total dimension, see here, total dimension is 86. Okay, total dimension is 86 mm. So when you are having this 86 mm, first we are going to create this circle. First you listen, okay, all of you listen. Then after that, once I end this session, you can ask your doubts, and I'll clarify it. The thing is that we have to create this part. Okay, first we have to create this part. Then after that we can assemble it. So today I'll be creating only this portion. You first understand what I'm teaching. Then after that you can go with all the parts section. So how we are going to create it? I keep it like this. Okay. This part list will be with you. Okay, you have to refer it in a sheet, and the same thing we should create it over here. Simultaneously, I'll keep it like this. Okay, that is better, I guess. Today we are going to create only this part, the first part. If you're having some doubt regarding this, you can ask me. See here, I have created only this much part, not to fully, only the baseline I have created. If you want to check how it looks, see now we are seeing it in diametric mode. If I see it in front view, then it will be looking like that only. You can see that. See this same dimension, we are seeing it. Okay, the same dimension. What is the dimension of that thing? You can check it over there. This will be having 30 mm, and this is having 86 mm. Understood, right? And also you can see it in this direction. See, dimension is similar. See, 30 mm is there, 86 mm is there. Let me do one thing. You can see here 30 mm dimension is there, and also 86 mm dimension is also given. The distance over here is 86, and the same thing is shown over here, 86, and 30 mm is shown in diametric mode, or in edit profile you can see that. You can see that this 30 mm is over here. Now what we should do, one cylindrical portion is created, then after that we have to create this 25 mm protrusion over here, circular protrusion over here. So for that I am going to select this end. For that what I have done, I have rotated in this orientation. I pressed mid button of the mouse, and after that I have rotated it in the required orientation. Like this I have rotated it, and after that I have selected this particular face, the rear face of the circular rod. So once I select that, that particular face will be converted into 2D plane. So on that we are going to create a circle by center only, by this center point only, and we are going to create a circle which is having 25 mm dimension. Why I am taking 25 mm dimension? Because it is having 25 mm circular protrusion. Okay, so here now I am selecting this dimension and I'm showing it as 25 mm. You can see that this is 25 mm, and if we select this circle, so this will be 30 mm dimension. Now we are clicking on protrusion, and once again I'm going with diametric mode, or we'll go with front view only. So what should be this dimension? What should be this dimension? See here, The dimension is not given. This dimension was given, it is 86, but here this dimension is not given. This dimension you can take it anything. I'll take it as 25 mm, or let us say 10 mm. We'll take it as 10 mm. You can take 10 mm, or you can take 15 mm, or you can take 25 mm. When the dimension is not given over here, see this dimension, the horizontal dimension is not given here. At that time, you can take any dimension over here. Today, I'll take it as 10 mm. Okay, 10 mm we can take it. Now 30 mm is given and 25 mm of this dimension is given, and also this 10 mm is shown here. So after that, we are going to click protrusion, which is finished. Okay, we are finishing that protrusion. Once it is created, if I go with visible and hidden edges, if I click on that thing, then it will show the outer boundary of this diagram. It is similar to this, but not exactly similar over here. Okay, it is not completely similar because we have to do this chamfering also, and we have to do this tapered slot also, and after that we have to create what is that, this round fillet also. So those are the things what we have to create. Now what we have to do, I'm going to once again diametric mode, or you can select it as front view only. Select this round option and click it over here like this. I'm going to select it, and I'll be selecting this inner circle. I show it with the shade with the visible edges. Okay, and I'm zooming this area by pressing control and scrolling the mid button of the mouse, and after that I'm selecting this particular edge. So I'll be selecting that particular edge, which is protrusion 2. Now the radius is always defaultly it is taken as 5 mm, and now we have to change it to 3 mm because it is given in this thing all unmentioned fillets and rounds should be having 3 mm. Okay, so here we are taking it as 3 mm, so that I'm changing it to 3 mm. So this became 3 mm. Okay, radius of 3 mm, and we'll be going with finish option. So select this line, change it to edge corner, change it to 3 mm, then click on round accept, then after that go with preview, and after that you can finish it. Okay, once you create it like this, you can see it in front view. See here, we can see that in the front view. This fillet or round option, we can see it in the front view. And after this, if you go with what is that, visible and hidden edges, at that time it will be clearly seen how it will be looking, and that particular way it will be seen over here. Then after that, we have to go with this hidden slot. So how to create that hidden slot? First, initially, we are going to see that we'll be going with front view, and I am selecting shared with the visible edges option. And after that, here we are going to create a slot over here in this particular position. We are going to create slot. So for that, what I'm going to do, I'll be creating once again diametric in diametric position. You can see that this entire section or entire part, it is perfectly sectioned in, or it is perfectly bisectioned. So here, if I click on this top view, see here, half of the portion is over here and half of the portion is below this axis line. If I take front view also, see here, half of the section is above and half of the section is below. If I take right view, okay, right view, what you are going to see, this entire circle is exactly sectioned in half. Here we are having one half, here we are having another half. If we take top half and bottom half, or right half and what is that, left half, they are symmetrically sectioned. So when they are symmetrically sectioned, we have to create it on the front view only for this slotting operation. So what I'm going to do, I'll be selecting this particular front plane, but I have to do the cutout. So I'll be going with cutout option. Whenever we want to remove some material, at that time we have to go with cutout option. And whenever we want to create some material, at that time we have to go for protrusion part. Okay, this protrusion icon or protrusion option will be creating this material like this, and cutout options will be remove the material. Here we are having revolved protrusion also, and here we are having revolved cutout also. Those things we are going to discuss later. Okay, we'll be going with this cutout option right now, and I'm selecting this cutout option, and after that I'm selecting this vertical plane, which is nothing but front plane in this particular software. I'm selecting this front plane, then I have to create that cutout option. So for that cutout option, what we should do, we should select a line which should be measuring exactly 30 mm. So from point on element to another point on element or point on this line. Once we are having this point on element symbol, then only we have to go with that thing. So for that, what we should see is uh, this relationship in IntelliSketch. We should be seeing all these options should be clicked on. Okay, all these options should be clicked on, and this point on element and end point and intersection point, these are very important in this particular topic. So now we are having one line which is measuring 30 mm. This is measuring 30 mm. And what is the dimension of this? This is 30 mm equivalent to 30 mm. What is the dimension between this line with the end of this rod? It is 25 mm. So I'll be measuring dimension or distance between this line end and with this particular line. So this should be how much? It should be 25 mm. Then once it is done, we should be knowing that from here to here it is 36.5, and we are having taper of how much? 1 is to 30, means for 30 mm 1 mm is reduced. So here 36.5, here it will be 35.5. So we have to create two lines. From this point we have to create a line which is measuring 36.5 mm, and here we have to measure, or we have to create another line which is measuring 35.5 mm. So I am selecting smart dimension and I am creating, or I am measuring the lines dimension. Here it is 36.5 mm, here it is 35.5 mm. And now we are having a tapered line from this 36.5 mm to, once I get this endpoint symbol, then only I have to click it. Okay, this line is tapered with 1 is to 30. for every 30 mm, this will be reduced by 30 point, sorry, 1 mm. So here we are having 35.5 mm. Now going with I'll be clicking on this return option. See here I can cut the, or we have to create, I can create the slot. So if I select with a non-symmetric extent, it will be cutting only one half section. Here another section we cannot create it. I want it in the both the direction. So for that what we should do, we have to go with cutout symmetric extend. So it is showing that you can cut this part in both the direction from that vertical plane or front plane. And what should be the dimension? For the dimension we have to go with this top view. Here they have specified it like it is 7.5 mm dimension. Okay, it is 7.5 mm dimension, and I'm clicking on finish. When we want to perform any what we say operation, we have to click on this finish option only, so that it will get end. Okay, so I'm clicking on this finish option. So we have created a slot over here, and that slot we can see it in top view, because here in front view you cannot see it. I can show it in visible edges. See, visible and hidden edges option. See that option is created. Okay, this option is created. The hidden edges, whatever it is there, that itself is shown over here. The slot is created over here. But the thing is that when we have created this slot, it is visible, or its dimension is visible only in the top view. So here if I select top view, you can see that this dimension is shown over here, but it is not having round, it is a rectangular section. We have to create it as a round option. So for that purpose what we are going to do, we are going to go with diametric option once again. Okay, I'm selecting round option. Okay, I'm selecting round option, and I know that it is 7.5. So round diameter is 7.5, and if it is round diameter is 7.5, then half of that is nothing but radius is nothing but, because we are showing it as radius, not as diameter. So for that purpose we are selecting it as 7.5 divided by 2. Diameter is 7.5, so radius should be 7.5 divided by 2. Diameter divided by 2 is nothing but radius. So that's why we are having 7.5 divided by 2. Okay. So this thing I have to select in which line I should select. All these end lines of this slot should be selected, or vertical lines of this slot should be selected. So edge 1, edge 2, edge 3 and edge 4 should be selected, which is nothing but 3.75 now, and it should be selected edge bar corner, and after that click on this round accept, so that it will be accepting that round, and after that if you want to see that preview, it will be showing preview, then after that you can finish that round. Okay, now there is a round, you can see that here we have performed a round option. If I select top view over here, you can see that this will be having 7.5 mm dimension. It is similar to this diagram. In top view it will be looking like that only. Okay, or if I go with the sketch option, or in the cutout option, we can see the edit definition. You can see that here we'll be having round parameter. Okay, and here the round radius is 3.75 mm. So here it is 3.75, and here also it is 3.75. So total will be 3.75 plus 3.75. How much it will become? Like if I have 3.75 3.75 plus 3.75 mm. How much it will be becoming? This will be becoming 7.5 mm. So that only we have made it over here. So 3.75 mm, 3.75 mm, that will be converted to 7.5 mm. So once it is done, you can see it in another named view also. Front view also. I can select it as shaded with visible edges. Now it won't be visible. At that time you have to go for only top view only. We can see that in the top. Now I'm changing it to once again diametric view. Okay. We have created this part, this entire part. We have created it. Okay, the first part, rod end part, we have created it. Now this has to be assigned with the material. Okay, this has to be assigned with the material because see here they have given it is FP41W 410W, which means it is having wolfram also, which is nothing but tungsten, and here we are having FP410. So this rod end has to be saved. Okay, this has to be saved. So for that, what we are going to do, we are going with this tools option, and here we are going with the material table. So in this material table, we'll be having several materials. You can select any material over here. I'll be going with FP410 means I'll be going with stainless steel 410 material. And after that, once I select this, all the material property of that stainless steel of 410 will be given over here. But instead of naming like this, what I'm going to do, I'll be naming it like FE-410W only, because if we name it like this, when I call it in the parts library, at that time the stainless steel 410 only will be coming instead of this FE-410W. So to avoid that, I'll be making it as FE-410, then I'll click on W. Okay, so it is FE-410W, then I'll be clicking on to apply model. So when I apply to model, then the color of that model will be changing. You just have to see that. Okay, I'll show you. It is slightly changed into bluish color. Whenever we are going with this stainless steel, at that time it will be slightly bluish, and when we are going with the cast iron, at that time it will be a little bit gray, and if I go with some gold property, at that time it will become a little bit orange color. If I select, see here, what is that? If I select gold, so it will be in orange color. So for every material, you can see that what color it will be changing. Preferably go with what is that? Stainless steel 410 only, because most of the material it is from stainless steel 410 only. Then after that, this has to be converted to Fe-410W. If you want to add it to library, because if you want to repeatedly call this material property, at that time you should go with this add to material library. You have to click on this add to library, then it will be added in the library. So whenever you are going with this thing directly, it will be coming like FE-410W. Now I'm clicking on this once again, apply to model. So once I this apply to this model, this will be selected, and here before saving this, we have to go to file properties, in file, and go to file properties, and in this file properties you have to go with this summary, and the title of this, select this summary, then after that title of this thing should be equal to whatever name it is given over here. So if you click rod end, the same thing will be coming when you are applying it in the when you call the parts library in the or parts table in the 2D diagram. Author you can specify it as your name. Here it is user is there. You can change it to your name, STG or like your name, whatever it is there, or your USN, whatever you want to keep, you can keep it there. Then just click on this OK. Then after that, what we are going to do, we are going to save it as for first part. So I'm going to create another folder over here, which is nothing but quarter joint, and this will be saved as part 1 rod end. So part 1 rod end will be saved so that whenever we are calling it in the assembly mode, at that time it will be easier for us. Okay. uh, I hope all of you understood this. Now I'm going to stop this class. Now all of you do one thing. Those who are having any problem regarding this, you can unmute yourself and you can ask me. Otherwise, I'll be stopping it over here only, and you can put your attendance in the chat box. Okay, put it as present. Put it as present. Only present. Nothing else. No, nothing is required. Okay, nothing is required. Just put it as present. Adnan Nadaf, for that, what you should do, first all of you should have it in that format only. If you are putting present, then you should be knowing that your name should be 2KL, then followed by your, what is that, name. USN should be there and name should be there. This is correct, okay. Sakshi, whatever it is correct. But Hardik Korvi and Adnan, all of you should change it to your dimension, okay. The
Yes,
other
sir.
format you should be doing it. Akshata, huh? You can ask the doubt.
Nothing, sir. By mistake, I did
Okay,
while changing my.
okay, okay. Change the name. Okay, you can change it, right? Okay, I'll give you access. Okay.